Hi, everybody, and thanks for coming tonight. Tonight I want to talk to you about a subject I've thought about for a couple of decades. And we're not going to solve all of these problems in 20 minutes, but we're going to try. So I'm going to talk to you about reconciling your data products data set with Stripe. My name is James Beswick. I'm a developer advocate here at Stripe. And before this, I worked at AWS, running the developer advocacy team for AWS serverless. In my spare time, which I wish I had more of, I like writing. But the most important thing on this slide is this QR code. So long after you leave tonight and you're using Stripe and you have questions and you think of something, the easiest way to reach me is by just connecting with me on LinkedIn and shooting me a message. So I'll show this at the end as well, if you don't manage to catch it now, but try to take a snap of that this evening. So we're going to talk about three things in the next 20 minutes. One is how this problem has changed over time. It's not the same problem we were dealing with 10 or 20 years ago. I'll go through two common scenarios and how you can think about solving them with some fresh approaches. And then I'll go through some tools, techniques, and best practices that can help you out. So when you boil down this problem, it comes down to this fairly simple statement, which is you want to ensure a list of X things matches in two places. And the X could be anything. It could be customers, products, orders, lists of movies, really anything you like. And the X can be any number, and the things can be those things. So you can also match in any number of places as well, but I'm restricting it for two just to keep it simple for the sake of what we're talking about. And so let's imagine in the Stripe context, since that's what we're talking about this evening, we're talking about ensuring a list of 1 million items in two places. So on the left, you have your own system, maybe some sort of legacy system with a products database, some sort of MySQL database perhaps, or DynamoDB. And on the right, you've got what Stripe knows about these products. And what you're trying to do is make sure these are the same in both places. Sounds like a simple problem, right? But often it's not because the systems don't agree. And this happens more and more often than we like to think. And it's a problem because that can result in lost sales because maybe your mobile app is talking to the wrong database, or customer frustration because you think you've got a product live when actually it simply doesn't appear in the app they're trying to purchase from. Or in some industries, compliance problems even. And then you get financial discrepancies when issues like price differences arise as well. And as developers, perhaps the biggest issue is this is often very tough to debug because the issues are transient. Now, I mentioned this problem has changed over time as well. So if you go back 10, 20, 30 years back to the mainframe era where many of these things started, this was a much simpler idea because you typically have one system with one view of the world, which is sort of simple, but it's not the same issue we're dealing with today. As we migrated into the client server era, where you've got one company, often with many systems and many databases, it's slightly different, but often you had control over all the databases because you knew someone in your company controlling those other databases. Again, a little bit different, but not that hard. When you move into the cloud or the SaaS environment, where the databases exist with a vendor or they're in the cloud, often you have no visibility into what those databases look like. So you've got one database you're managing versus one you can't really see. And so we really like the cloud and the SaaS era. We don't want to give up all the benefits that come with that. But this problem that comes with it is reconciliation between these data sets. The other thing that's really insidious about this problem is it tends to grow as you grow as well as a company. So if you think about when you're a small startup when you first begin, you might have one or a dozen products going in your 1 to 100 journey. Your product database typically consists of things like the categories and hierarchies of your products, inventory levels, perhaps you're storing in there as well. You might have some rich descriptions. You might even include some binary data like images and that kind of thing, along with your cost data and margins. And then you look at Stripe's product model, and this will be the same for any type of SaaS vendor. What you find is that's a more generalized model that's trying to work for a large number of customers. So it won't really match your model very similarly. But in this early stage, it doesn't particularly matter because you only have a few dozen products. So you might be able to use manual scripting or even just ClickOps through the front ends just whenever things change to make sure that they agree. But scale tends to change everything. So as the number of products you have grows and the amount of business you have grows, all those things you did when you were small no longer work. So that manual verification approach, where you're clicking through the front end, you can't do that with tens of thousands of products. And the same with scripts that might work on your laptop that you might be run every night. That stops working too, because perhaps the number of changes you have, they're changing multiple times per minute. And so at this large scale, all sorts of things that used to work start to break, and you end up with these perhaps constant changes throughout the day that you have to think about. So as a result of that, there's two common scenarios that we see, and there are many more, but I think these are two worth talking about to give you a sense of the sort of problem you're walking into. So the first one, the simple case, is you're going to sync changes from your workload to Stripe. Now, in this diagram, I'm using an AWS infrastructure because just so many of our customers are using AWS, but really you could use anything such as Cloudflare, Google, Microsoft, and so forth. So in this case, you've got a products database. Here I'm using DynamoDB. And when changes are made, we're collecting those changes and pushing them to a worker. And you could use a container or a serverless compute platform like Lambda here. And then you'll call an API call to update Stripe to let it know about the changes that you're seeing in your database. And then Stripe then returns a 200 response when those changes are made, and now everything is right with the world. That Lambda function might look something like this. So very simply, you have a Stripe library that you're setting up, and maybe an update product function. And inside a try catch, you're calling the stripe.products.update API, handing it your product ID along with the shape of the new product, and then just calling that. And at the bottom is just setting up the product and calling the function. A fairly naive function, but that would do the trick. But the problem with this kind of approach is that it tends to break at scale or when there are any sorts of issues. And these are the sorts of problems you can face. So if the Stripe API is unavailable for any reason, and you should always assume an API might not be available, the changes will be lost. There's nothing in that code that's going to look after anything that's not being committed. Also, a service like Lambda at scale gets throttled. So if you have lots of changes happening in your database, Lambda might not be able to keep up with those. And the same problem happens. Changes are happening on your side that never make it through to the vendor. Also at scale, there are API limits to consider as well. So Stripe has API quotas, 100 requests per second by default. And so if you go with a very busy system, it's possible you exceed those. And in all of these cases, you're losing data and you haven't figured out what you're going to do when that happens. So one solution to this is actually a fairly simple one, but we don't see customers using this enough. And that's to introduce a queue to your architecture. So in this case, I take the products database, and instead of feeding them straight to my compute solution, I put a queue in the middle. Here I'm using SQS, but you could use any cloud provider's queue equally well. So in this case, these changes go to this queue. Then the Lambda function in this case would pick up those changes from the queue and then invoke the API as before. And even though this is a small change, it has a couple of major benefits. One is that items are now being fetched from the queue at a steady pace. So if you find the database is producing lots and lots of changes, it doesn't matter. You've effectively smoothed out the demand curve, and you'll be calling the API at a constant rate. Also, if there are any problems in terms of failures with the Lambda function, either the service is down or there's a problem in your code, those items are not being removed from the queue until they're being processed successfully. So just this one change gives you two major benefits. And if we look at the change to what the code would now look like, it's a similar sort of function as before, but now I've got a Lambda handler in this case, and I can take a batch of messages from SQS in this event payload, and I can iterate through those messages calling the API. And the one thing I've introduced here is a flag, all successful. So if any one of those messages go wrong, so-called poison pill, I can then take action. Another thing I showed at the bottom here is if one of those messages is bad and I want to throw an error, I can do so, and the Lambda service will then automatically retry my code with exponential backoff without me having to write any particular handler to do that. So a very small change here suddenly makes this code approach much more resilient. So that's scenario one, but let's look at a more complicated one with scenario two, where you're not just changing things on your side, things can change in both places. And this is actually more realistic with something like Stripe, because we see people going into the dashboard and making changes to their product database that then is separate to the changes they would see in their own database. Now, historically, the way to deal with this has been to use ETL, the so-called extract, transform, load approach. And put very simply, what this means is you're going to extract the contents of both databases using things like SQL dumps, or SQL queries and database dumps, pull them out, and then you're going to transform that data because typically they're not in the same shape. And you're going to compare to see where the deltas are, and either then choose to reload the entire database or just the changes back to each side. And so ETL is a very established pattern, but it isn't free and it comes with its own set of problems. The most common one is that this process is periodic. It's not real time. So if you have a very busy system where changes are appearing in both sides, you can find that you've got update conflicts between two databases. You have to decide how you're going to handle those. It also can be fairly complex and cumbersome, especially if you need to make any changes to either database. You have to update this ETL process so it doesn't break. So let's look at another approach to this, again, using this Amazon type approach, but instead I'm going to take the feed coming back from Stripe as well. So the top half of this diagram is the same as before. We've got the products database submitting changes to the queue. The queue is being handled by the Lambda function as a worker. It's then calling the API of Stripe. But in this case, Stripe is then emitting changes as they happen. So Stripe has a feature called event destinations, where as these changes are being recorded into Stripe, those can be sent back to your AWS account. So this then appears in a partner event bus in the event bridge in the region in which your application is running. And this is actually a bit better than using a webhook in many cases because events just arrive on the bus without you having to manage a webhook endpoint. Once those events arrive in that event bus, you can create an event bridge rule because you don't always want to process every single event that's arriving. So you can filter there. And then once you receive those, you can choose to send those to another location. And again, you can use a queue here. So put those events that you care about into a queue and then have another worker function in Lambda processing that queue where you can then update your database. And the same thing is happening in reverse here, where the queue is smoothing out the number of changes. So suddenly there's a huge number of changes coming from Stripe. You're smoothing out that curve. And of course, if there's a problem with your database or a problem with your Lambda function, the items are not being removed from the queue, just as we saw before. And so this is a very, very resilient way to handle large numbers of changes without you having to write very much code. I also just wanted to mention here, there's a few tools and techniques in this whole space. So I didn't invent reconciliation, it's been around for decades. But I do see many developers trying to build too much by themselves. And there are many, many tools in this space. So depending on your cloud provider, your runtime choice, your database choice, you'll come across a range of different tools, just to name a few like AWS Glue, Apache Kafka, and Great Expectations. One of the big decisions you need to make in this type of flow is whether you want to invest in the real-time approach or focus on batch. And you'll only know the answer to that based upon what it is you're building for your business. So I'm generally in favor of real time. I think it's easier to maintain as a developer, even though it's harder to set up. But it's not always the right solution because often you have products that simply don't change that often, so it's not worth the lift. So if you're using a batch processing tool, often this is better for deep reconciliation, can be cheaper to run in the long term as well. I also wanted to mention a few best practices in this space since, again, it can get fairly confusing. I talked about two different locations where you're trying to sync databases. Often there are many more. And obviously I'm talking about one vendor with Stripe, but people have lots of vendors now with Salesforce and other systems as well. So there's a tendency to think about the system you're building only having one source of truth, typically the legacy system that you're coming from. But that might not be the right approach. You might be better using whatever system is the expert for that particular topic. So you might decide your ERP system is good for product specs, but something like Stripe is what you'll trust for payments, since it's always going to have a more up-to-date and accurate view of your payments than a copy of that data in your own system. You might find that you have a separate inventory system that controls that, or customer data, maybe you trust Salesforce more than the duplicates. But it's a bit of a mental shift to go from having one system that you trust from absolutely everything to realizing the truth of the data might be separated in lots of different places. Another thing I see often missed in these designs by customers is understanding and implementing idempotency. So there's a tendency as a developer when you build things to test locally and find it's calling the API and it's fine, and ignoring many of the problems that happen at scale or in production. Remember, things that happen 1 in a million times or go wrong will go wrong much more frequently when you're handling millions of transactions. Those sorts of blips you see in the long tail do actually happen every day in larger systems. And idempotency can go a long way to helping you solve some of these issues. So if you don't handle idempotency, especially with something like payments, what happens is you call an API, let's say to charge a credit card, and you don't receive a response, and so you call it again, you get a response, without realizing you've charged a credit card twice. And so you want to be able to take actions where if you have a network drop off or you miss a call, calling an API twice doesn't have an unintended side effect. So here's a little bit of code that illustrates this, but one of the subtleties here is that calling an API twice means that to be idempotent, you want exactly the same response the second time, not just something that says, oh, I've seen this before. So in this case, it shows how that can work, where in the call, you first check to see, given the UUID, if it's been handled before, and if it has, it returns the ID for that existing product. Otherwise, it goes ahead and calls the API. It's actually not particularly hard to implement, especially with Stripe, but most vendors have an approach now where it'll already have this baked in. You just have to choose to turn it on and use it in the API. Conflict resolution strategies are another really important thing. And again, in dev and test, you don't tend to see these problems because you're dealing with small workloads you're controlling in the way that you test. But when you're dealing with complex systems with hundreds of changes a minute, you're definitely going to see conflicts. And so imagine you have changes in the same piece of data in databases A and B. What do you do? Well, it's a lot easier to decide what you're going to do if you make these decisions beforehand. So, for example, if system A has new information, maybe you decide to use system A. Or if system B has a more complete version of the data, maybe that's what you decide to use instead. If you have a critical field mismatch, such as a price, where you'll actually lose money if you get this wrong, maybe you flag that for manual review and don't do anything until a human gets involved. Or if it's a non-critical mismatch, such as a title where there's a word difference, you have some sort of predefined rule that decides which copy wins. Again, only you can know for your business what the rule should be, but I strongly suggest thinking about this before you're sat in production, dealing with the problem in real time. Soft deletes are another thing I don't see people using enough. So data storage is incredibly cheap in 2025. And so you don't really need to delete data in most cases. So if you think about doing an actual delete in SQL, where you do a delete from a table, your data is gone. And if you need to restore it at any point, you have to go through logs or backups to bring it back. It's not trivial. Whereas often you don't need to do that. You can set a field in your table as an identifier for deleted. And when you do the delete, just trip the flag. Obviously, you have to make sure any queries and views that you're using respect the flag. But if you need to restore the data, it's then fairly easy just to flip it back so the data exists again. Tombstones can also be incredibly useful. So if you're using events in this case, like in the event bridge case I showed, when you delete some data, publish an event, let people know that's the point you did that at, to let other systems take action as well. So this is the reconciliation problem. I did say we weren't going to solve all of it in 20 minutes, but hopefully gave you a few things to think about. The key thing about this is that you're going to see this problem more and more. So as you start to integrate with other systems, your data is split across different databases. There's no way you're going to avoid this. It's really a matter of accepting this as a fact of life. But it tends to become technical debt because you don't deal with it as a startup when you're small, but you tend to see it more as you grow. I talked about two common scenarios. So the one-way example, you have to consider various things like API limits. All vendors have them. You should know what they are and where you're likely to trip them. You can use queues to smooth out the traffic to avoid hitting those as well. But it does mean you should think about handling errors. You will see errors either through API limit trips or because a vendor is down or because a network is down or other problems as well. So you need to figure out a retry policy as well. On the two-way journey, often we've looked at using ETL as a solution to this, but we have more real-time tools that you can think about using as well. So event processing with tools like event destinations. Make this much easier to be able to take a stream of events from a vendor and then handle that and push that back into your database. So you have something that approximates real time. Please use queues. Queues are cheap. So I remember the days when we used to have servers with queue software installed. You had to set it up and it cost tens of thousands of dollars. These days, in one line of code, you can spin up a queue in any cloud vendor, and it's absolutely crazily cheap to use these. They do all sorts for us in terms of providing resiliency and smoothing out traffic. But I often see in architectures, they're simply not used enough. So definitely think about where you can drop in queues into your architecture. And then I talked about some of the best practices, but out of those, definitely think about idempotency as where you've not applied it already, where you need to go back and add it before it becomes a problem. But there are a few other things we talked about too.